So, good morning students. In this video, in this class we are going to see the second unit of the power system, that is load flow study. In the load flow analysis of the power system, there is one important concept, that is bus classification is there. The bus classification is nothing but classification of various buses in power system. So you will be going through this video to understand what is a bus and what are its various types, why the bus concept is used, and what is the main purpose of load flow analysis, or otherwise it is called as load flow study. So kindly watch this video to understand, to have a better understanding. Thank you.
Hello, in this video we would like to discuss what is the meaning of the load flow or load flow analysis inside the ETAB program. So what is the meaning of load flow? This load flow analysis or the load flow study case is used to provide a numerical solution for our power system. For example, the single line diagram which we drew before, we would like to get a numerical solution for this system. So by using the load flow analysis, we can get the number one, compute the steady state values of the voltage and the equivalent phase angle. We have the voltage and its own phase angle. And also we can get the real power or real active power and the reactive power flowing through the entire power system. All of this will help us in designing of the substation, selection of the cables used, transmission lines, insulators, circuit breakers, and etc. Depending on the power flow, the reactive power flow, the current flowing, voltage drop, all of this will help us, the information which we get will help us in identifying how to size our cables, size our transmission lines, selecting insulators, and the circuit breakers for protection. What are the different load flow iteration methods inside the ETAB program? Gauss-Seidel method, the Newton-Raphson method, fast decoupled methods. All of these methods are classified according to number of iterations performed by the program, how fast the system can converge to a solution. Okay, so in the ETAB program, you will find that we have different iteration techniques which we can choose from. As an example, the accelerated Gauss-Seidel method, the accelerated Newton-Raphson, and also Newton-Raphson and fast decoupled methods. All of them are in ETAB, and you can of course try any of them inside the ETAB. As an example, what's the difference between them? Regardless of their mathematical equations, the fast decoupled methods have a shorter computation time than the Newton-Raphson, than Gauss-Seidel. Okay, so fast decoupled are considered as the best because it has a smaller Jacobian matrix, okay, than the Newton-Raphson. Now, in our power system, we have a different types of buses. Number one, we have the load bus or the PQ bus, okay, and from its name, we know the P and Q, and from its name, we have a load. So it is a bus in which our load is connected, and we already know the active power and reactive power absorbed by this bus or absorbed by the load. However, we don't know the voltage and phase angle of the bus. Another type of buses is the generator bus or the PV bus. We know the active power P from this bus and the voltage of this bus, and it is connected to a generator. That's why it's called a generator bus. So we know P or active power and the voltage. PV, we know the active power and the voltage. However, we don't know the Q or the reactive power and the phase angle of the voltage. The slack bus or the swing bus or the reference bus. This is the largest generator bus or the bus in which our largest generator connected to it, and it's only one bus. In this bus, we know the voltage and the phase angle. However, we don't know the reactive power or active power. So from this three sentences, we see that we have three different buses. Each of these buses, we know two quantities. We know two quantities such as PQ, B and Q, generator bus B and V, reference bus, voltage and phase angle. However, in the other buses, we don't know another two quantities. Here in load bus, we don't know the voltage and phase angle. In generator bus, we don't know reactive power and phase angle. In slack bus, we don't know the reactive power or active power. So we have four quantities in each bus. We know two and we don't know the other two. Remember that the slack bus is only one bus and it's connected to the largest generator. In the next video, we are going to do the load flow analysis for the single line diagram which we draw before.
Who knows you is how much.
So, in this class, we saw about the various types of buses and what is a bus, etc. So, in the next video, we will be seeing about formulation of the load flow problem. What is load flow problem and how to formulate that. Thank you so much. Thank you for watching this video.